When we look up at the night sky, space feels calm, silent, and endlessly beautiful. The stars appear fixed. The moon feels familiar. The planets move in predictable paths. From Earth, the universe looks peaceful, almost timeless. But beyond this quiet appearance, space is changing. Slowly, invisibly, and in ways most people never think about. For thousands of years, space was dangerous mainly because it was far away. Humans could only observe it from the ground. The risks stayed distant and theoretical. But today, humans are no longer just observers. We are active participants. We send satellites, probes, telescopes, and astronauts into space every year. And as our presence grows, so do the dangers. Space is not becoming hostile all at once. There is no single event, no sudden disaster. Instead, space is becoming more dangerous in layers over time, driven by physics, technology, and human activity. To understand why, we must begin with a simple truth. Space was never designed for life. Space was never safe to begin with. Space is a near-perfect vacuum. There is no air to breathe, no pressure to protect the human body, no natural shield against radiation. On Earth, we survive because of layers of protection. The atmosphere absorbs harmful radiation. The magnetic field deflects charged particles from the sun. Gravity holds everything together. Even our planet's rotation helps regulate temperature. In space, none of these protections exist. A human exposed directly to space would lose consciousness in seconds. Body fluids would begin to boil. Radiation would damage cells almost immediately. Without protection, survival is impossible. For decades, technology acted as a barrier between humans and these dangers. Spacesuits, spacecraft hulls, and space stations created artificial bubbles of safety. But those bubbles are fragile, and now the threats surrounding them are increasing. Radiation is quietly becoming a bigger threat. One of the most serious dangers in space is radiation. Unlike heat or impact, radiation cannot be felt immediately. It does its damage silently, over time. There are two major sources of space radiation. The first comes from the sun. Solar radiation includes high-energy particles released through solar flares and coronal mass ejections. When these events occur, massive waves of charged particles race through space at incredible speeds. On Earth, most of this radiation is deflected by the planet's magnetic field. Astronauts do not have that luxury. The second source is cosmic radiation. These particles originate from distant supernova explosions and other extreme cosmic events. They travel across the galaxy at near-light speed and pass straight through spacecraft walls and human tissue. As humans plan longer missions, especially to the Moon and Mars, radiation exposure increases dramatically. A trip to Mars would expose astronauts to more radiation than any human has ever experienced. Over time, radiation damages DNA. It increases cancer risk. It affects the brain, the nervous system, and even cognitive function. Some studies suggest it may accelerate aging. Unlike many dangers, radiation cannot be fully blocked. The thicker the shielding, the heavier the spacecraft. And heavy spacecraft are harder to launch. This makes radiation one of the most limiting factors for future human exploration. Space debris is turning orbit into a minefield. One of the fastest growing dangers in space is entirely human-made. Since the beginning of the space age, thousands of satellites have been launched into orbit. Along with them came discarded rocket stages, broken components, paint flakes, and fragments from collisions. Today, Earth is surrounded by a cloud of space debris. Some of these objects are large enough to track. Many are not. Even a fragment the size of a screw can travel at speeds exceeding 25,000 kilometers per hour. At those speeds, impact energy is devastating. A collision with a piece of debris can puncture spacecraft walls, damage solar panels, disable satellites, or endanger astronauts during spacewalks. The International Space Station regularly performs avoidance maneuvers to dodge incoming debris. The real danger is a cascading effect. When two objects collide, they create thousands of new fragments. Those fragments increase the chance of future collisions. This chain reaction is known as a runaway debris scenario. If this process accelerates, certain orbits could become unusable for generations. Human activity is slowly turning Earth's orbital environment into a hazardous zone. The sun is more unpredictable than we like to admit. The sun appears stable. It rises and sets every day. It has done so for billions of years. But beneath that stability lies constant violent activity. The sun's surface is a boiling ocean of plasma. Magnetic fields twist, stretch, and snap. When they release energy, solar storms erupt. Some solar storms are minor. Others are powerful enough to disrupt technology across an entire planet. In space, these storms are far more dangerous. A strong solar storm can overwhelm spacecraft electronics. It can damage satellites, corrupt data, and disable navigation systems. For astronauts outside protective shielding, exposure can be lethal, as we rely more on satellites for communication, navigation, weather forecasting, and global infrastructure. The impact of solar activity grows. Space is not empty or static. It is shaped by forces that change constantly. Microgravity slowly changes the human body. Gravity is one of the most underestimated protections of life. On Earth, gravity shapes everything. Bones grow strong because they carry weight. Muscles remain healthy because they work against resistance. Fluids settle naturally in the body. In microgravity, this balance disappears. Astronauts experience bone loss at rates far higher than elderly patients on Earth. Muscles weaken. Vision can deteriorate. Fluids shift toward the head, increasing pressure inside the skull. The longer humans stay in space, the greater these effects become. Even after returning to Earth, recovery can take months. Some changes may never fully reverse. As missions grow longer and deeper into space, the human body itself becomes a limiting factor. Space weather can disable entire systems. Space weather refers to conditions in space caused by solar activity and cosmic radiation. Unlike Earth weather, it cannot be avoided by sheltering indoors. Satellites are particularly vulnerable. A single radiation spike can cause electronic components to fail or behave unpredictably. GPS systems can degrade. Communication signals can distort. Power grids on Earth can even be affected by geomagnetic storms triggered by space weather. As space infrastructure grows, so does its exposure. Human civilization is becoming increasingly dependent on systems that operate beyond Earth's protective shield. The further we go, the less protection we have. Low Earth orbit still benefits from partial protection by Earth's magnetic field. Beyond that, protection drops sharply. The Moon has no atmosphere and no global magnetic field. Mars offers only weak shielding. Deep space offers none at all. Future explorers will face environments where every system must work perfectly for survival. Rescue will not be possible. Delays in communication will stretch minutes or hours. Medical emergencies will require self-reliance. Distance itself becomes a danger. Space is getting crowded, but not organized. There is no global traffic control system for space. Different nations and companies launch satellites independently. Orbits are assigned, but enforcement is limited. Coordination is improving, but slowly. As commercial launches increase, congestion grows. More objects mean more potential collisions. More collisions mean more debris. Without careful management, space could become less accessible with each passing decade. Human ambition is outpacing human preparation. The desire to explore is deeply human. From crossing oceans to climbing mountains, progress has always followed curiosity. Space feels like the next natural step. We want to go farther, faster, and more often, not just to explore, but to live, work, and even vacation beyond Earth. Plans now include permanent lunar bases, long-duration missions to Mars, privately operated space stations, and commercial space tourism. What once required decades of government planning is now being accelerated by private companies and global competition. Launch costs are falling, access is widening, timelines are shrinking. But ambition does not remove risk, it often hides it. Technology improves rapidly, but the human body does not evolve at the same pace. Physics does not negotiate. Radiation still breaks DNA at the cellular level. Vacuum still causes fatal decompression. Extreme temperatures still destroy materials. High-speed debris still delivers catastrophic impact energy. Many proposed missions assume future solutions that do not yet exist. Radiation shielding that is light enough for deep space travel remains theoretical. Artificial gravity habitats are still experimental. Long-term effects of partial gravity, like that on the Moon or Mars, are largely unknown. Even basic medical care in deep space faces enormous limitations due to delayed communication and limited supplies. Space is not becoming evil, just honest. Space is not hostile in a personal sense. It does not target humans. It does not resist exploration. It simply exists exactly as it always has. What we often describe as danger is actually honesty. Space operates under laws that were never designed for life. There is no atmosphere to soften mistakes, no gravity to hold bodies together, no magnetic shield to filter radiation, no environment that forgives small errors. On Earth, life evolved inside layers of protection. Atmosphere, oceans, magnetic fields, and stable temperatures formed a cradle where mistakes could be survived. Civilization grew because Earth absorbed our failures. Space does not do that. As humans move beyond Earth, we leave behind the conditions that made trial and error possible. In space, small failures escalate instantly. A cracked seal becomes lethal. A delayed maneuver becomes a collision. A momentary loss of power becomes catastrophic. A quiet reminder from the cosmos. Space does not warn us loudly. It does not announce its dangers with explosions or alarms. Its threats are gradual, cumulative, and patient. Radiation builds slowly. Debris multiplies silently. The human body weakens without gravity. Technology ages under constant exposure. The universe remains vast, beautiful, and awe-inspiring. But it is also indifferent. As we continue to reach outward, we are reminded of a simple truth. Exploration is not just about courage or curiosity, it is about respect. Because space has never been safe, and it never promised to be.